Hello, today we're looking at notes 2-5, graph absolute value inequalities. All right, so a couple of steps that you want to follow and jot down. Plot the points of the absolute value function. So graph the points for the function first, then decide on the type of boundary line. So if your inequality symbol has the or equal to underneath, you're going to use a solid line because some of the solutions to the inequality will lie on that line. If your inequality is not or equal to, then you're going to graph using a dashed line because the points on that line are not solutions to the inequality. Last but not least, you are going to decide where to shade. So you will shade above the boundary lines if the inequality is greater than or equal to, and you will shade below the boundary lines if the inequality is less than or equal to. All right, so I've just got two examples for you. Hopefully this will go pretty quick for you. So if y is greater than absolute value x plus 1 minus 6, then I'm going to graph that graph first. This absolute value has been transformed left 1 down 6. Left 1, 1, 2, 3, 4, 5, 6. I've already put the new origin. And no stretch or shrink or reflect, so I know I'm just using those original values. So this guy will look like this, right? Those will be the dots. I'll draw a couple more. So next, once I plot the points, that was step 1. Step 2 is decide on the type of boundary. That does not have the or equal to. If it does not have the or equal to, we are going to use a dashed line. So this is how we'll draw it, kind of like not solid. Okay, going on forever, not solid. Same on this side. Okay, so now we've got our line. And then last, decide where to shade. Okay, that is greater. So that means we're going to shade above the line. So look at this line. If I go above it, that would be this way. Above, above. All this stuff is above. All right, so just to show you, that means above, so I'm just going to keep on shading above. So what all this means, because you know it's got to have a meaning in math, is that any point I pick, pick this one here, the point 2, 1, okay? That coordinate, any coordinate in this shaded region is a solution to this inequality. If I plug in 2 for x here and 1 for y here, that will be a true statement. So 2 plus 1 is 3, and 3, absolute value of 3 is 3, and 3 minus 6 would be negative 3, right? And if I plug in 1 for y, is 1 greater than negative 3? Why, yes, it is. Okay, so that made a true statement. However, if I pick any point out here in the non-shaded region, pick any point, plug it in for x and y, it will not work. It'll give you an untrue statement. Something like 1 is bigger than 2, which it's not. So same goes for the line. We dotted this line because if you pick a point that's on the dotted line and you plug it in here, it will not work. These points on this dashed line are not included in the S in the solution set. Okay, so let's look at the next graph. On this one, I've got an absolute value parent function shifted right 3. So I've gone ahead and drawn my new origin here, and I think you've gotten enough practice with graphing to know that 2 out there means you're stretching it vertically by 2. So instead of left 1, up 1, I go left 1, up 2. Instead of left 2, up 2, I go left 2, up 4, right? I'm doubling those values. So that's what that would look like. Before I go ahead and draw my line, I've got to look at the inequality. My inequality on this one does have the line underneath, or equal to, meaning I can go ahead and I can shade, or excuse me, I can draw a solid line, okay? It doesn't have to be dashed. Solid line. Okay, now this symbol here means less than or equal to. So that means I'm going to look at my line here, and I'm not going to go above. I'm going to go below. I'm going to go down below my lines. So everything below. Okay, could I also go over here? Well, yeah, this, I just stopped it there just because, but does it keep on going forever this way? Yeah. So I could go below that line too. Okay, I could go all the way below it. So this whole section here is your solution set. Okay, I pick any of these points in the shaded region and it will satisfy that inequality. It'll be a true statement. Now on this particular graph, I could also choose a point on the line because this is a solid line. These points, if I plug them in here, will work. Check it if you don't believe me. Let's try this one here. This is the coordinate 1, 2, 3, 0. So if I plug in 3 for x, 0 for y. 3 minus 3 is 0. Absolute value of 0 is 0. 0 times 2 is 0. Is 0 less than or equal to 0? Why, yes, it's equal to 0, so it's a true statement. Okay, so just understand what the dotted and solid line mean.